Okay, good morning. I am Dr.V.T.Priya, Assistant Professor, Department of Chemistry, K.S.Rangasamy College of Arts and Science. Today we are discussing about the topic is photochemistry. What is mean by photochemistry and what are the laws used in photochemistry, photophysical process and photosensitization. First of all, what is mean by photochemistry? It is a branch of chemistry that deals with the molecules absorbed the light radiation. Next, what is mean by photochemical reaction? There are two type of photochemical reaction. First one is photochemical reaction and another one is thermal reaction. First one is what is mean by photochemical reaction? When the substance absorbs the light radiation, this is called as photochemical reaction. Best example is an ordinary plant molecule absorb the carbon dioxide and atmospheric hydrogen in presence of sunlight and chlorophyll. It will produce carbohydrate and oxygen molecule. In this process, chlorophyll acts as a absorb light energy. This is a photosensitization reaction. Example for photosensitization reaction. And another one is thermal reaction. In this reaction takes place by the absorption of heat energy. Example for thermal reaction is calcium carbonate in presence of 1000 degrees Celsius to form carbon dioxide and carbon monoxide molecules. Here thermal energy is supplied for this reaction. And second topic is laws of photochemistry. There are 5 types of laws used in photochemical reaction. First one is Beer-Lambert's law, second one is Beer's law, and third one is Lambert's law, and fourth one is Groth-Draper law, and fifth one is Stark-Einstein law. First discuss about Beer-Lambert's law. Here the absorption of light radiation is directly proportional to concentration and length of the absorbed molecules. Mathematical representation equation is A is equal to E into Cl. Here A is the absorption of light radiation, E is equal to molar coefficient, and C is equal to concentration, and L is equal to length of the substance. And second law is Beer's law. Here, when the intensity of light radiation is directly proportional to concentration of the substance, mathematical equation is A is equal to E into C. Here A is equal to absorption of light radiation, E is equal to molar coefficient, and C is equal to concentration. And third law is Lambert's law. When the intensity of light radiation is directly proportional to length of the substance, mathematical equation is A is equal to E into L. A is equal to intensity of light absorption, E is equal to molar coefficient, and L is equal to length of the substance. And fourth law is Groth-Draper law. This is the first law of photochemical equation. Groth-Draper law deals with when atom or a molecule absorb the light radiation when a chemical reaction takes place. Otherwise, the chemical reaction does not take place. This is the Groth-Draper law. And another law is Stark-Einstein law. This is the second law of photochemical reaction. This law, when a substance or a molecule takes place the light radiation, that light radiation used for one quantum of light radiation is used when the chemical reaction takes place. Otherwise, the reaction does not take place. E is equal to N into H mu. Here E is equal to one quantum of Einstein energy is used for this reaction. N is equal to Avogadro number, and H is equal to Planck's constant, and mu is equal to frequency. And another process is photochemical process. Here in this process there are 3 types of reaction takes place. First one is non-radiative process and second one is radiative process. Here non-radiative process there are 2 types. First one is internal conversion and second one is inter-system crossing. Internal conversion takes place by the process of same transition takes place. That means singlet to singlet transition or triplet to triplet transition takes place. And second one is inter-system crossing. Inter-system crossing means here transition takes place between singlet to triplet transition takes place. This is called as inter-system crossing. And another reaction is non-radiative transition. Here 3 process takes place. First one is fluorescence, and second one is phosphorescence, and third one is chemiluminescence. First we discuss about what is meant by fluorescence. Fluorescence means when an atom or a molecule absorbs the light energy, the ground state molecule absorbs the light energy, it will goes to triplet state. Here triplet state, the molecules will be unstable because the lifetime is very small. So the molecules return to ground state with the emission of some light energy. This process is called as fluorescence. Example for fluorescence mean chlorophyll and some type of minerals undergo fluorescence reaction. And another reaction is phosphorescence. Here when the atom or a molecule absorb light energy, it will move to molecule ground state to excited state, and here the lifetime of excited molecule is very large, so the molecules returns to ground state with the emission of light radiation. And the difference between fluorescence and phosphorescence is when we cut the light radiation, the emission of light radiation is as soon as cut will, and the phosphorescence, when the passing the intensity of light radiation, cutting means, and the emission of radiation is continuously emitted. This is the main difference for fluorescence and phosphorescence. And another reaction is chemiluminescence. Chemiluminescence, when the chemical reaction takes place with the release of energy. This is called as chemiluminescence. And last topic is photosensitization. What is meant by photosensitization means which substance induces a photochemical reaction, that substance acts as a sensitizer. This process is called as photosensitization. Best example for this photosensitization reaction, photosynthesis process. Here the chlorophyll acts as a photosensitizer. An ordinary plant molecule absorbs the carbon dioxide and water molecule in presence of sunlight. In presence of sunlight and chlorophyll, it will produce carbohydrate and oxygen molecule. Here chlorophyll acts as a photosensitizer. This process is called as photosensitization. Next we discuss about nuclear chemistry. Nuclear chemistry deals with what are the changes involving the nucleus molecules. Here nuclear chemistry deals with the nucleus undergo what are all the changes in a chemical reaction. The very fundamental particles used for the nuclear chemical reaction is proton, electron, neutrons, positrons, and some other particles, gamma rays like alpha ray, beta ray, and gamma rays. First of all, what is meant by atomic number and mass number? First of all, what is meant by atomic number means number of protons and electrons combined to form an atomic number, and mass number is number of difference between atomic number and mass number is called as neutrons. Next we will discuss about what there are two type of reaction in nuclear chemistry. First one is nuclear fission reaction and nuclear fusion reaction. Nuclear fission reaction is barium and 3 molecules of barium and 3 molecules of neutron combines with the proton molecules to give a krypton and barium with the release of some amount of energy. This process will be continuously flowed by with the help of neutron, releasing the neutron molecules. This is a nuclear chain process reaction. That means the reaction will be continuously followed by with the help of neutrons. This is called as nuclear fission reaction. And another one is nuclear fusion reaction. Here 4 molecules of hydrogen molecules in presence of nuclear reactions to form a helium molecules and with release of some amount of energy. This type of reaction is called as nuclear fusion reaction. Main difference between nuclear fission and fusion means nuclear fission process is with release of some amount of energy, and nuclear fusion reaction is with the gain of some amount of energy. This is the main two process for the nuclear reactions. And another one is stellar energy. Stellar energy, ordinary hydrogen molecules react with the atmospheric hydrogen, oxygen to form a helium nucleus and with release of some amount of energy. That is called as stellar energy.